Dependent and independent events, and of course this is related to conditional probability. Events can be independent, meaning the probability of each event is unaffected by other events or other knowledge. Now, the event itself may well be affected. And let me explain that because it's a point that not many students seem to understand. Let's suppose we had this Venn diagram and we had people who liked newspapers and people who like magazines. And let's just say we had 4 people in each section. So we've got 4 in the middle there who like both. If I asked you for the probability of somebody liking a magazine, you can see that there are 8 of those out of the 16, so the probability is a half. If I ask you for the probability magazine given newspaper, then we know that we are only looking at the people in this section. But 4 of them like magazines out of the 8, so the probability is a half. These events are classified as independent because the probability does not change. But note that the event has changed because once I know that they like newspapers, I cannot select those 4 people. So independence is about the probability of the event rather than what can actually happen. That said, now let's go ahead and look at a couple of examples we have here. So tossing a coin. Each toss of a coin is a perfect isolated thing. What it did in the past will not affect the current toss. So even if you know it came up heads the last 5 times, the probability of getting a head this time is still a half. So the chance is simply 1 in 2 or 50%, just like any toss of the coin in the past or in the future. That is, of course, assuming that it is a fair coin. So each toss is an independent event. But events can also be dependent, which means their probability can be affected by previous events. And we've seen this in some earlier examples. But let's have another example here to underline what we're saying. So what we have here, and we're looking at this diagram, is a bag that has 2 blue and 3 red marbles in the bag. What are the chances of getting a blue marble? Well, you should know that it's 2 in 5 or 2/5 because there's 2 blue marbles out of the 5. But after taking one out, you change the chances if you take one out and you don't put it back in. So this diagram shows the situation where you took a red one out, and this shows the situation when you took a blue one out. So the next time, if you got a red marble before, the chance of getting a blue marble is then 2 in 4. If you got a blue marble before, then the chance of getting a blue marble next is 1 in 4. See how the chances change each time. Each event depends on what happened in the previous event and is called dependent. Note, if you had replaced the marbles in the bag each time, then the chances would not have changed and the events would be independent. So that leads us to 2 situations you need to look out for in questions. With replacement, the events are independent and the chances don't change. That's because if you replaced it, you'd be back to the original bag. Without replacement, the events are dependent and the chances will change. One thing you should know, when events A and B are independent, the probability of A and B is equal to the probability of A times the probability of B. And it's probably worth mentioning as well that if they're independent, the probability of A given B is just equal to the probability of A, because knowing B does not affect the probability of A.